Hello, everyone, and thank you for joining. My name is John Foley. I'm the Managing Director of the Safer Buildings Coalition, and this is the IWCE virtual event. This subject is session number VT11, Public Safety DAS, Focus on Network Infrastructure. We have a great professional panel here to discuss today. Let's get right to it. Here are the topics that we'll be broadly covering today: the introductions, followed by a review of system topology basics. We'll then have a roundtable discussion on a number of topics like design and deployment challenges and approaches, noise and interference, and other topics. And then we'll have a quick recap. This is a pre-recorded session that'll run for 45 minutes. At the end of the 45 minutes, there'll be a live Q&A. You can start submitting your questions now. If you look at the bottom of the screen, you should see a button that's either a chat or a Q&A button that would allow you to submit questions. But as I mentioned, this is a pre-recorded session, and the live Q&A will happen immediately following. Thank you. And with that, let's introduce our panel for today. Starting off with Michiel.
Hi, John. My name is Michiel Lotter. I'm the CTO at Nextivity. We're an OEM developing in-building solutions and a relatively new entrant into the public safety system market.
Thank you, Michiel. Al.
Hi, my name is Al Leffler from EMR Corporation. I've been in the wireless industry for over 35 years. We get involved in everything from base antennas and indoor antennas all the way up to complete combining networks and in-building solutions. Look forward to working with you and helping. Thank you.
I appreciate that. Thank you, Fernando.
Hello, I'm Fernando. I'm the Director of Engineering at Fiplex Communications. I've been involved in projects and designing hardware for public safety communications for the last 16 years. Thank you.
I appreciate that. Thank you. And Matt.
Hi, my name is Matt Lunny. I'm the Sales Engineering Manager for Coma Telecom. We are an OEM of public safety BDAs, fiber DAS, and battery backups, as well as being an OEM of cellular DAS and passive infrastructure.
Very good. So these are the broad topics that we'll be covering today. The topology, we'll talk a little bit about the codes that are requiring that these systems be installed. We'll talk a little bit about the difference between active and passive, and what about campus considerations? How is RF testing performed? Design and deployment challenges. We're going to have a great conversation about noise and interference, key installation considerations, and finally, a little talk about the pandemic, the new normal, impacts on logistics and some key takeaways. And with that, let's talk about what the problem is. So the problem has to do with physics, frankly. Radio waves propagate through materials at different ways, depending on the type of material, the thickness of the material, and the frequency of the radio wave. The higher the frequency, the more poorly it propagates through materials. And then there's also materials that are more difficult to propagate through. We'll talk about that in a second. It's really important that people inside buildings be able to dial 911 and be quickly and accurately located, that they be able to receive mass notification text messages, and that first responder communications work regardless of whether they're using the push-to-talk radio or cellular communications, okay? And the FCC shows that a 1-minute improvement in response time to a 911 call would save 10,000 lives a year. So this is a big problem. So let's get right into it. Here's some of the physics. So on the right-hand side, you see a picture depicting a special kind of glass called low-E glass. And it lets visible light pass through, but it's reflective of infrared light and UV light and also radio waves, okay? So weak signals on the other side of that glass. And regular glass, a 6mm pane of regular glass, would only decrease the signal by about 17% at 900 megahertz. But as you can see, a double glazed low E glass would reduce the signal by over 30 dB, or pretty close to 100%. So this is a challenge, and the way that we get through that is to install a system in the building. I'll be going to Al Leffler now to talk about some of the common topologies that are used for solving for different kinds of buildings. Al, we have on the screen now a diagram of a passive system and another diagram of an active system. And, what is the use case for each, and what are the main differences between the two?
Well, on both the illustrations, either taking out the BDA or bidirectional amplifier makes the system what is called a passive distributed antenna system, or DAS. And it's just meaning that in passive, you want the type of system that would cover maybe a very small area, because you have such strong signal outside the building, but inside the building, you just really need to distribute that energy from the antenna on the top of the roof, which is seen as a Yagi or a directional antenna that's pointing at either a cell site or a public radio site, public safety site, taking that signal and running it through the DAS. When you add a bidirectional amp, you put in amplification. You actually amplify that signal, and more illustrated on the right would be picking off the signal, again, over the air using what's called a CAI or common air interface, and then bringing it into the bidirectional amplifier, and then re-amplifying it and distributing it throughout the facility. Again, one on the left, small, very limited area, one on the right, a larger distributed system. And it works out best doing those kind of things, and it's more economical if you can use one versus using a more active system.
So in the system on the right, which we're calling an active system, it actually has fiber optics, so it converts the RF into optical signals, sends it out over fiber to the remotes on each floor or every other floor, and then the remotes convert it back to RFs over coax. So coming to Matt now. Matt, what are some of the requirements if you have to put fiber optic in? Those remotes out on the floor, do they each get their own power supply? Do they each know their own backup?
So that's going to depend on the specific equipment that you put in. Typically for a traditional DAS, you would have a remote unit located in this case on both the second and fourth floors with a dedicated battery backup for it. Some of your other options include running composite fiber, so that's both copper and fiber optic cable to the remote unit to power it from one central location. So there are multiple ways of doing it. The biggest key really is making sure you're complying with any local codes.
Thank you. And in this diagram, you can see cables that are basically running vertically or backbone cables. And then you see other cables that are, for the most part, running horizontally or distribution. And later on, we'll be talking in the fire codes section, how they're treated differently and why one is more important than the other. So moving on. Al, take us through this slide. This is your slide. Can you take us through some of these basics, please?
All right, what this is to illustrate is you want to minimize complexity wherever you can in a DAS or an in-building system. Just for the example here, in the Bay Area, California, there are 2,600 line items of licensees at 700 and 800 megahertz. That does not even include VHF or 450 megahertz or any of the others. So that if you have to have a channel change, and that's depending on the authority having jurisdiction, that booster has to be reprogrammed if it's a Class A type booster. It might require a field visit by a tech to make that happen, or if it has remote access, you can do it over a network, over an internet network. Regardless, you're going to have record keeping that's involved, and you got to keep those things up to date all the time. Some of you might all remember the rogue BDAs that were out in the network that Nextel provided out in mass, like over 10,000 BDAs back 15, 20 years ago that were crazy to keep records on. Again, you got to have an agency that takes the responsibility for keeping all the records right. You look at a Class B booster in comparison, you don't require reprogramming. If the new channel is within their passband that's been developed due to the filtering, it works out really well. So it's Class A versus Class B. There's an expense component to it, and you should be just mindful of it. Thank you.
Great, thank you. So let's get into a little bit of a discussion about the actual fire codes. You mentioned knowing the requirements of the jurisdiction Michiel, can you talk to us a little bit about the code compliance requirements for these systems?
Yeah, thanks, John. I think the first thing to say is that there's generally no statewide standards that exist for in-building coverage solutions. There are very often cases where a local AHJ, authority having jurisdiction, would have his own specific requirements for his own system. So the first thing that I would say is that whenever you're going to install a system, you've got to have a great line of communication with the AHJ to understand what is the actual requirement in that specific area where you're going to do the installation. You can't just go to a general document and find all the information that you need. Now, having said that, there's really, for me, there's like 3 different areas of code compliance that you have to focus on. So the first one that's listed on the slide here is UL 2524. So this is a relatively new standard, and it is a major step forward in creating solutions that are compliant with other parts of the codes, such as NFPA 1221 and so on. And 2524 deals primarily with the construction, alarming, safety-related aspects of the equipment itself. Not so much the installation part of it, but the equipment itself, to make sure that we have equipment that that is safe to operate and provides you with all the capabilities that you need later on to be able to, for example, to connect to a fire alarm panel to be able to do alarming. So we're seeing the first 2524 compliant equipment hitting the market right now, and so I think big step forward. The second part of code compliance is something that often is sort of glossed over a little bit, and that's the FCC Part 90 rules, which actually define the RF capabilities of the radio systems. Any piece of equipment that is put on the market must comply with the FCC rules as part of the normal certification process, but it is equally as important to any of the other code compliance issues that we have, even though we don't spend as much time on it. And then finally, we've got what I would call more the installation deployment style code requirements. So we have NFPA 1221, 1225, IFC 510, lots of different names. NFPA 1225 is also a newer code that basically defines how to install the system and what the operational characteristics must be like. What do I have to do when I pull the cables in the vertical direction, horizontal cables? Do they need to comply with 2-hour fire rating, for example? And when the system is installed, what does it need to look like? What's the performance criteria that the system needs to have before an AHJ would be able to sign off on it? So you have to look at all 3 of them and basically address all of the aspects in each one of these areas.
Thank you. So Fernando, how are public safety systems different from and similar to a commercial cellular system? Are they pretty similar, or are there some key differences?
Well, yeah, definitely there are key differences and that's probably one of the major differences between the different type of technology you find in cellular and public safety. Basically, in public safety, you have to be code compliant. Everything that you see on the screen, you have to make sure you meet with it. Of course, that it changes a little bit between different jurisdictions, but definitely for a cellular, there is not requirement of UL 2524 for cellular infrastructure, not Part 90 rules, and definitely not NFPA 1221. So the difference is that essentially. One of the big differences in the piece of hardware is the code that it should comply in, and it's everything you see on the screen right now is what you should comply if you want to do any piece of hardware to support first responders.
So Matt, coming to you, suppose there's a building that has already an existing commercial cellular DAS in it, and now there's going to be a public safety DAS too. What kinds of things do you have to take into consideration? Can you have 2 of those systems? Can you have a public safety DAS and a cell DAS in the same building, Matt?
Yes, you absolutely can. And depending on the jurisdiction, you may be able to use the same passive infrastructure. Some companies used to make a shared active infrastructure as well for public safety and cellular. That's going to be more code driven than it is going to be technology driven. So if code allows it, you can absolutely share the same active equipment and same passive equipment. Typically, however, either code or budget doesn't allow that because public safety code usually requires either 2-hour ratings or battery backups, and backing up an entire cellular system ends up costing a lot more money. In terms of sharing the same building, whether you share the same passive infrastructure, typically you would need proper filtering to make sure the cellular signal does not interfere with the public safety signal, or vice versa, just because you have wideband amplifiers in all equipment. And to fit filters inside these small boxes, the filter roll-off is not exactly sharp. So it does end up rolling off into pass bands of the other network. Even with not shared infrastructure, so you have a completely separate public safety system, completely separate cellular system, a lot of times you need to be mindful of where you're placing antennas and make sure you don't put the antennas too close to each other. Otherwise, it can still interfere with each other.
I appreciate that. Thank you. So let's talk a little bit more about use cases and topologies. So there's a lot of folks that think about this. He was seeing up there a picture on the screen of a fire marshal, and he's looking at a fire alarm panel. And I know that a lot of the thinking that comes along here comes rooted in sort of fire alarm basics. And one of the basics in fire alarm is it's better to have a separate fire alarm system in every building rather than a hub and satellite situation where you would have one building that had a master unit and then all the other buildings were remoted off of that main. And the concern there is that if you lost the main building, you'd lose fire alarm in all the other buildings. And that's some thinking that leaks over in the minds of fire marshals. But that might actually be a bad thing in the in-building public safety for a particular reason. I'm going to show a slide here from Kumba. And can you take us, Matt, through this issue? So here we have a campus environment with multiple buildings. Some of them are in a direct line of sight to the radio tower. Take us a little bit through this scenario and what the solution might be.
Yeah, so this actually comes from a real world scenario that I've seen before. You have 3 buildings in very close proximity to each other. So imagine these are just right across the street from each other. You have maybe 20 feet between buildings, and the donor antennas can be less than 100 feet apart from each other. So what you can have is, even if all 3 of these buildings individually with a single BDA have good isolation with itself, the isolation between buildings is so low that you get oscillation between buildings. In this case, building 4, the signal would reflect off of the low E glass in building 1 and be received by building 5's indoor antennas, and then that would get retransmitted back from building 5 to 4. So you have sort of a figure 8 oscillation between buildings 4 and 5 in this scenario. And if you're deploying it as a system integrator, maybe one system integrator deploys building 4, one deploys building 5. They have no idea that there's a building right next, a building with a public safety DAS right next door, and there's no way for them to know that they need to check the other building for isolation. So one of the good ways to make sure this doesn't happen is when you have a campus environment, deploy a fiber DAS. So in this case, you could have a public safety head-end in building 1 with a master unit and remote unit, and you would run fiber from building 1 to buildings 4 and 5, and each one of those would have a remote unit with no off-air signal. So there's only the service antenna side of the DAS in buildings 4 and 5, and that would completely mitigate the oscillation between buildings.
So in this case, in this drawing, you could see that the donor antenna now is only on building 1, right?
Yes, that's correct. So this actually explains exactly what I was talking about. You would have building 1 with the master unit and remote unit. That's the only direct line of communication with the donor tower. And then buildings 2, 3, 4, and 5 all have fiber feeds from building 1 and distribute the signal coming from the master unit in building 1.
Now, from a deployment standpoint, Makil, You know, obviously it would be nice to know ahead of time that this was the intent, to see the entire campus as a holistic design rather than treating each building individually. So if I was bidding on a project and the RFP just gave me the address of building 1, you might very well, or maybe building 5 even, you might very well specify an off-air system. But if you knew in advance there were going to be 5 buildings, you might consider optical or digital or other situations. Is that correct? I mean, what advice do you have for property owners and others who are deploying here in building a wireless plan? How important is that?
Yeah, I think it's a great question. It's also a very difficult question because, you know, as Matt said, someone can come in, you know, years later and have to install the system and they have no idea what's going on in the environment. So I think there are 2 things that are quite important. I think the first one, as mentioned earlier, right, you've got to have great communication with the AHJ, right? They could and should know the location of other systems in the area, and it's good to have a discussion with them, you know, upfront and trying to figure out, you know, what would the best solution to a problem be. And secondly, I think that walking the site, getting as much data as you can, doing pre-tests, knowing the environment that you are going into is also, you know, critically important to be able to come up with a solution that fits the you know, that fits the specific case that you need to deploy into. I think there's another issue that I think we'll see become more and more important, and people will be able to utilize it a little bit more, and that's, you know, just a broader understanding of the RF data that you can typically gather from a system, right? And even when you install the system and you look at the performance characteristics that you can see in the system as it's operating, right? You can make good judgment calls and say, you know, this doesn't look right. You know, if I look at the signal levels at this point, I'm expecting it to be, you know, X, but I'm getting Y. We need to be able to get the integrators to have a much better understanding of those sort of parameters so that they can quickly realize, right, that something is going on here, something needs to be investigated further.
I appreciate that. Thank you. So getting the design done right up front is very, very important. Al, this is your slide. Can you quickly take us through this slide of what the correct design considerations ought to be?
Well, these are a number of the things that we've seen in our experience of doing these for nearly 30 years. And that item number 1 about more gain doesn't really mean that you're going to get better coverage. I can't emphasize that too much. We have provided, provisioned, offered, given away stepper attenuators to people that think that if 50 dB of gain is great in the system, well, why not run it at 70 or 80 or 90 dB? It is a major problem. The other thing is you got to choose between a Class A and Class B. It really is very dependent on the environment. Certainly Class A for urban and a very high noise area. Class B might be suitable also for urban or suburban or rural. Frequencies and system interference exist. They can be optical, they can be RF-wise, there could be a lot of things that can impact. So regardless, again, either a Class A or Class B, you want the proper filtering to be designed into the system. Coverage, what does the AHJ expect? Does he want the stairwell? Does he want to be below ground in tunnels and basements? It really has a lot to do with him. Systems monitoring, more recently over the years, NFPA has had 7 crucial aspects that they want monitored. Battery backup, in a lot of cases we've seen systems that need only 12 hours, others specify 24, and I'm sure it's pretty varied throughout the country. Coverage outside the building, that has become sometimes an issue where that signal from the DAS is covering 100 feet outside the building, so it's interfering with the macro system. You don't want that. Getting down to just general coverage aspects, about 100-foot radius you might expect out of an antenna for VHF. That drops to be maybe about 75 feet for UHF, and 700, 800, 900 megahertz, about 50 feet ought to, you know, do really well. Again, having that correct system design and the filtering, very, very crucial. Many don't understand that very important consideration and aspect. Thank you, John.
Thank you very much. And Fernando, so this slide talks about noise, uplink noise and interference. Tell us about what's on this slide. What are we seeing here?
Well, that's what we're looking in there is basically what happens when there are 3 base stations, and all of them are being affected by uplink noise. Basically, that's the answer to what happens with when a base station gets hit by uplink noise. The answer is that the coverage gets reduced. Generally, many people has a tendency to believe that the downlink coverage is given by the reach of the downlink signal, but that's not the whole story. You also have the uplink signal, and basically when the ability of from a base station to hear low signals also gives you a coverage edge in the uplink. And what you're looking in there is a study that was done over 3 base stations, in which the original coverage is the red area. Everything was beautiful back then, and then the yellow area is what the reaction of the coverage when 10 dB of uplink noise is being applied to each one of the base stations. Basically, those portables that were at the edge of the red coverage zone are not longer being captured by the base station, or at least with good quality. So that's basically the effect of the reduction of coverage because of an uplink effect, of uplink noise aggregation on the base station.
So what you're saying is that originally, before the uplink noise was injected into those 3 systems, the coverage would be the entire red area. All of those red areas had coverage. Exactly. And then when the uplink noise, then the coverage area shrinks to just the size of the yellow areas. Is that correct?
Yes, exactly.
Got it. Okay. So what do you do about that?
Well, it's there are think about that what might cause an uplink noise reduction. We just saw the effect. Now, what can cause that? And let's go to 2 scenarios. For start, anything that has a donor antenna is potentially an uplink noise, a source for uplink noise generation. So but having said that, there are 2 scenarios: a BDA or a DAS that is not performing well, maybe having isolation problems, maybe having a problem with the uplink chain, or any problem that is actually rising the uplink noise above normal. So that's one thing. And the other thing is that the intrinsic noise that each system out there will have, even though it's well installed. So when you increase the number of well installed systems, you might have a similar effect, or maybe you'll have that effect. And that's when you need to come up with different solutions. When you are in case A, in which you're having systems that are creating problems, is where you start seeing codes doing things about that. You have UL 2524, you have NFPA 1221 talking about that the system they should include an oscillation detection and isolation measurement to avoid oscillation. So with that, if that system comes to trouble, the jurisdiction can get an alarm and go to hunt the problem. If there is a BDA that is causing problems and it's not triggering the alarm, then the jurisdiction will have to hunt the alarm, but differently. We'll have to go on the streets with antennas trying to find the source of a problem, and that's that's a huge problem, because you never know how much time it will take to find the problem. And then you have the case B, in which we have everybody's doing the right thing, actually configuring the uplink gain not to be excessive, and not creating any, very easy to see problem. But then you have the effects on the technology you use in the BDA. If you have a class B BDA, then any uplink noise amplification will create noise. It is very common said that, okay, but I can do an uplink amplification even though it's broadband, but if I make sure that I don't rise the noise too high, I'm not gonna reach the base station with such noise. The thing is that one system is not doing that, but then you do building next door, and instead of, and now, the density in the air is getting a little bit closer to the base station, and like that. And once you reach 100 BDAs, then there is, all of them, they are creating noise in the base station. And whose fault is that? The first one or the last one? Well, all of them. They're all doing an approach to increase a little bit the noise in the base station. And when that situation happens, it's very difficult for a jurisdiction to actually overcome that problem.
Thank you.
Now,
so Matt, I have a question
yeah.
for you. So so this noise is happening. How are the local jurisdictions reacting to this? And here I'm probably more talking about the radio system operators than necessarily maybe the fire code officials, you know, because they're the ones that have to deal with this. How are they reacting to the problem of noise, and what are some of the approaches they're taking to address it?
So that's going to vary throughout the country. So some jurisdictions, or really jurisdictions or radio communication shops, whoever ends up making the rules, are enforcing some requirements. So I've seen requirements such as 65 dB of gain limited on the uplink, which makes it so you have to design, instead of, like what Al said, maybe a 50-foot coverage radius, you have to go down to a 25-foot coverage radius to get proper signal back to the donor tower with only a 65 dB gain maximum on your uplink. So they're sort of forcing your hand at making you have a higher antenna density. Some jurisdictions are going to new testing requirements. So a lot of, I wouldn't say the AHJ, but whoever is making the final sign off, whether they're from, whether they're the fire marshal or from the radio communication shop, they're looking at the uplink noise floor, whether it's connecting directly into the BDA and looking at the uplink noise floor with a spectrum analyzer, or getting out on the roof and standing in front of the donor antenna and making sure your noise floor is low enough. They're also going through and checking the near-far effect right out of the BDA and making sure your signal difference between the near and far communications are not too high.
I appreciate that. Thank you. So Al, in this situation, here you have obviously some noise has been injected into the system. Whose job is it to go find that noise and mitigate it? How does the jurisdiction go about finding out? You know, I don't know, maybe they file an SEC complaint to the SEC, but how does someone go about finding the source of the noise here and getting it corrected?
Generally, John, the first step is to have a integrator, a dealer, installer, a guy that you can go to that has the right testing equipment. He can really narrow it down and figure out through his scope what network analyzer, where maybe those signals are coming from. He can triangulate, he can really work on those noise issues. And then he'd get back to the manufacturer and say, this is what I'm experiencing, what can I do about it? Generally, if it falls right on, it's a 2A minus B or whatever that math is, turns out. Sometimes it falls right within the passband, and there's little you can do other than by physically changing some of the parameters, the directivity of the antenna, putting some things in that you got to do because it's within the passband of the system or the filtering that's involved or whatever. There's a lot of things that are in the toolbox of the manufacturer to design for these type of things. But there's, you know, we've identified as a panel a lot of things from near far to having too high signal gains and all, to really see that these are really problematic things, and you got to be dealing with people that understand that part. And one of the biggest things that we run into on the filtering aspect is that there's a common belief that because it's a channelized Class A booster, it doesn't, it's immune to the need for filtering. Well, the signal levels are still there. The interference is still there. The only thing is it might decrease the system range or the coverage or the penetration into different areas. Regardless of it being Class A or Class B, there are interferers to deal with, and it's the people that are manufacturing and designing the systems that usually help out in figuring out how to get them resolved. They are challenging. I saw things today that really are very challenging.
Well, we certainly have a lot to deal with on the design and the interference side. Let's talk a little bit about on the deployment side and the installation side. Nikhil, this is your graphic. Let's talk a little bit about the logistics of getting one of these systems installed. Can you take us through the process from the system integrator finds out that a system is needed all the way through to closeout? What's the process?
Yeah. So I think the first thing that you have to do is make sure that you know what the requirements are. As we said earlier, there are many requirements that are local. You got to understand the local requirements. Talk to the AHJ, make sure you understand exactly what frequencies need to be boosted, where all the high sites are located. Sometimes you have, and it's really important because it also helps you to know what the future plans are. For example, as you can have a high site today on mountain 1, but we know that the AHJ knows that they're busy actually configuring a second site on a different mountain for a different network, and they want you to actually boost the signal from both of these high sites into the building. So you have to understand, you have to get that information to understand exactly what the requirements are and what frequencies it is that you need to boost and what all the local code requirements are. Then when you get to the site, I think there's a few things that are quite important, right? So I said the frequency configuration is one thing. As Al mentioned, if you have a Class A device, you need to be able to configure the system with the correct frequencies that need to be boosted. You need to know exactly where the donor site is located, and that's important because it allows you to do a link budget. So, we've spoken about interference here, we've spoken about something, the near-far effect. For me, it starts with understanding what the link budget looks like, right? How much power do I actually need to put into the donor antenna to be able to reach the high site at the level that is required by the AHJ? So we've seen a number of radio shops, for example, in the local requirements would now state, I want to receive the signal from your system at a specific level, right? I want to receive it at -95 dBm, for example. So if you know what that number is, then you can do a good link budget calculation to figure out, what is the gain distribution and so on that you need to have in the system to allow you to have a system that can operate safely. Now, link budgets sometimes, can be a little difficult for people to calculate. There's lots of little things that you need to take care of. But I think it's one of those things that there are lots of resources available, and there are some vendors that will be able to provide you with the tools that you need to be able to do a really good job, from a link budget calculation point of view. And then, once you understand your link budget, you can go ahead and basically configure the system, so load the frequencies, and then figure out what your uplink and downlink gain settings need to be. I haven't spoken about the location of the server antennas. I think that's a separate issue. You need to design and figure out where all those antennas need to go. Where on the floors do they need to go? You have to think about what areas in the building are considered to be critical areas. So, for example, the machine room where the water pump sits to supply the building with the sprinkler system, that would be a critical area, right? And typically you need to have 99% of those areas need to be covered by your system. So once you've done your design of where all the server antennas need to be located, you can go ahead and you can set the system up. There are a few jurisdictions now as well. The code NFPA 1221 has a requirement which says that you need to have 20 dB isolation between your donor and server antennas. There are some jurisdictions that change that requirement, but that could typically be an area that's quite difficult to measure. There are, I think, like Washington, D.C., Office of Unified Communication, have a special procedure that you have to go through, for example, to prove that you've met this requirement. So things like that make it quite difficult, and the smarter the equipment is, right, the easier it is to basically be able to do this installation.
Okay, thank you. I appreciate that. So Matt, deploying these systems, who is the most important person to deal with? The fire code official, the radio shop people, the building owner? If you could, how do you get these people all rassled up together and get them involved? Whose job is that?
I think that's always going to be the job of the system integrator. The system integrator needs to know who in that jurisdiction is the right person to talk to. Obviously, the building owner is probably paying for it, so they want to be constantly talking to the building owner. And then on the permitting side, talking to the local building office just to get their permit set approved, know whether it's the AHJ or the radio communication shop who they need to talk to. So the system integrator is sort of in charge of getting everybody on the same page.
Now, what about, Al, independent testers? Some of the feedback that we've been getting is that there are building owners that are frustrated that the company that comes out and does the baseline testing tells them they need a system, tells them they need a system in 100% of the building, gives them, and then turns around and gives them a quote to purchase, furnish, and install a system. And then they have someone else come and run the test and have those people say, you're fine, you got plenty of signal in here. Who should they believe? What's the best practice? I mean, what should we do here?
If I was to contrast what has evolved in our industry is maybe the bells and whistle phenomena that we can do all these whoop-de-doo things for a radio system, and they are being put out to the industry that, yeah, we can give you the monitoring, give you the capability, give you the battery backup, all those really neat things, and display it on a GUI that you can look at, and it really is very compelling. But what they don't understand is that if you're not working with someone that understands RF from the get-go, you're going down a bad path right from the beginning. So that guy that is working to help you in doing that, if he's the wrong guy as a project manager or a designer, or he knows this other part of it, if you don't have the right alignment with the person that understands it and understands radio systems at its very fundamental level, which is signal level, penetration, all those things that RF does, you really are going down a bad path. And in a way, you almost want to partition one from the other, that get the expert to do the design and then have a third party that might do the testing or do a pre-testing and show that data. If they're doing both the furnishing and provisioning of the system along with the testing, I might have some question about the validity of that information that you get.
Kind of like grading your own homework, right?
You bet.
Yeah. Fernando, I have a question for you. So down in Florida, and I know you've got a lot of experience in Florida, there are some of the code officials that are saying, well, I don't know how to calculate for uplink because you can only measure downlink. So if it's neg 95 downlink inside the building, someone gave them a magic number of 15 dB and says, well, that means that you are at neg 110 on the uplink at the tower, and therefore it will fail according to code. Is there some magic number that if you know the downlink number, you know the uplink number, and what's the reality of that discussion? How does that really work? And what should people really do?
No, it's every jurisdiction will have its own way. You'll like Matt said, maybe in the area you mentioned, you have the jurisdiction with donor antennas, hunting for noise in the roof, and they try to get a number. I don't know if how much that's based maybe on their experience, how they came up with that number, but there is no magic in there. That's when I believe that we as OEMs, what we should do is make sure we have equipment with enough features inside so the uplink noise doesn't become a problem. And I believe then we will get, not rhythm, but at least we will iron a little bit the ways of trying to find and mitigate the uplink noise or to test the uplink noise from the jurisdiction. Having said that, with for example, if you have there are jurisdictions that to stop the problems that they have with the uplink, they are changing the technology of the BDAs. They are allowing in their area to Class A, for example, and it has to be with uplink squelch per channel and per time slot. With that, they make sure that the amplifier is not going to do any uplink application unless it's not being used inside the building. So it becomes pointless for them to just go up there and hunt noise with an uplink, with an antenna in the roof. So and they're changing that because they are realizing that that's the way. I mean, a class A or class B BDA may have a 20 dB difference in uplink noise generation, and in terms of times, that's 100 to 1. It means that one class A can, one Class B can create the same amount of noise that 100 Class A can create. That's already been realized, and jurisdictions are trying to solve the problem, from the beginning, and not trying to hunt, the noise and try to see if the configuration is well done or not, with rules of thumbs that sometimes are difficult to predict from where they took it.
Okay. Well, that's really good. Now, I'm very interested in a very present tense logistical question. I want to go through to the OEMs and then finish with Al. The pandemic has changed a lot about how not only the use cases, but also what it's like to operate a business. So starting with Komba. Matt, any impacts to the supply chain that you've had to take into account, whether it's, parts, components, shipping, any of those kinds of things? How has the pandemic impacted the OEM community?
So there's obviously a shortage of supplies. I'm sure everyone's seen it, whether it's something they're buying for their home or for their business. But it's sort of taught us to stay on top of our supply and our shipping, just to make sure we have enough inventory to always be able to ship out to our customers. So although we've had delays on equipment, just having the stock in our warehouse, being able to ship it out locally, it's really taught us that that is a very important thing to have at all times.
Fernando, how about your company? How has the pandemic impacted logistics for you?
Well, it's obviously it is impacting. You're going to see that, but the way to overcome that and not to affect your business and the run rate of the production is to have several local suppliers for each different part. And that's a way that, even if one of your suppliers gets affected, you have other two options of approved, suppliers. And that's a way to overcome that for us, at least.
Thank you. McKeel.
So we saw a tightening of supply, I would say, more so in the first half of the year, but I think much of that is behind us now. We have seen an increase in freight costs as well. Some of that has been significant, especially for international freight. But I think even that is starting to stabilize now. So I think we're getting back to sort of business as usual. And I do think that the pandemic has created some opportunity as well. We've seen a spike in business, for example, to school districts, where it's easier to get in now and be able to do deployments, right? There's no one there. So it's much easier to execute some of the projects. So it's a little bit of, I would say, a little bit of hit and miss. Some projects absolutely have been delayed, but we've seen some that have been accelerated as well, just by nature of the fact that it's now easier to get in and out of the buildings.
Good deal. Okay, so this is our wrap up. And what I'm going to do is I'm going to go around to each person and ask for some key takeaways. So Al, starting with you, what do you hope that the listeners take away from this discussion? If they could take one core idea away, what is something really important that you want the listeners today to take away with them?
That they align with someone that really understands RF and is integrator savvy, understands how to put all the components together, has had maybe a number of years in experience in doing these, and that they also realize that the filtering aspects or getting the signal through with controlling the noise and interference is a lot more complicated than might seem on the surface. It seems that from the whole panel of folks that we were on today, that has come up a lot, and you can't minimize that. So you want the right people to be working with.
Thank you, Al. I appreciate that. Fernando, one key takeaway that you would like to make sure that people remember from this panel, what, if you had your wish, what would that be? I think Fernando looks like he's frozen there. So I'm going to go to Matt. Matt, one key takeaway, if you could make sure that they had it for this panel, what would you hope that that would be?
Yeah, I think my key takeaway is know your geography. Know the building that you're going to be installing in, know where it's located, know what's across the street, what's behind it, where the tower is, and most importantly, know the AHJ or the radio communication shop. And like Al said, know an expert in the community so you can align with them if needed. So really just become an expert in the location you're working in, and you'll be an expert in the field.
Fantastic. Thank you. Looks like we got Fernando back. Fernando, key takeaway that if someone were watching this, you would hope that they took away from this, what would you want that to be?
Hello, yeah, good to be back. I align with what Al said, to really know, be sure that you are working with somebody who knows RF. And I also will align with Matt says that has to be local. That's very important. So they really know the desires of the local jurisdiction. And then what I would like to add to that is that that we as OEMs are all doing of efforts for in the future to have a better technology that actually mitigates so many of the problems that we were talking. And there is light behind the tunnel. There are a lot of things that can be done in order to avoid to have so much problems with the uplink noise, the near far, and there is technology today that can help you with that.
Fantastic, thank you. And to close out the session, the recorded session, Nikhil, what is the key takeaway that you hope that people get from this session?
I think that a lot of important issues have been raised, but I agree also with Fernando. I think that there are technologies available today that is now being applied to this specific problem that make it a lot easier to do a great job when you're installing a system within a building. And I think listening to what has been discussed here today, hopefully that gives folks the right questions to ask when they are selecting an equipment vendor, to know that the equipment vendor fully understands the issues and that they have addressed these issues. And I think if we can do that, then we can open up the community of people that can install these systems to be broader than just RF savvy people. We need to be able to involve fire alarm installers, right? Other people, to grow the group of people that can actually go and install these systems in the buildings that require them, because it's really important, right? And we can't keep the group closed. We got to open up the group.
Well, thank you. So we have a diversity of thought there, and I think that's going to be a great table setter for the Q&A session that's coming up next. So that concludes the pre-recorded panel. In just a moment, we're going to be going live to the Q&A with this group. I've been asked to tell you this. Please do join us now for an interactive Q&A session by clicking on the link below, where we will be answering any questions in the chat or Q&A feature, and also taking any further queries you may have. Just a reminder of who we had on here today so far: Nikhil Lotter, Chief Technology Officer for Nextivity; Al Leffler, RF Systems Consultant with EMR Corp; Fernando Samariva, from the Director of Engineering from Fiplex; and Matt Lunny, Sales Engineering Manager with Kumba. I'm John Foley, the Managing Director of the Safer Buildings Coalition, and we'll see you right now in the Q&A section. Click the link below. Thank you.
Hello everyone. I understand we're live now, and that you can see 4 panelists in the screen right now. Thank you for joining this session. Now we will be going over different questions that you sent during this session. One of it is the question for Alan. Says, is having the highest gain possible more important than having adequate level for a DAS system? If you can answer that, Alan.
The feeling is that a lot of systems that are deployed are put in with high levels of gain just in case they need it. And invariably, the systems have to be turned down, otherwise they go into what's called oscillation. It's like having 2 mics or a speaker and a microphone at an audio concert, where you put the microphone right next to the speaker and you get the audio feedback. Same thing is happening at RF or in the RF frequency levels for where wireless is. You just want to have enough gain to do the job. So really, if a 50 or 55 dB gain unit device, that's what you should work with rather than trying an 80 or 90 dB gain system just because you could.
Yeah, that's a good answer, Alan. Yeah, it's indeed like that. Then let me turn this over a little bit to Matt. Matt, you were showing in the in part of your presentation a DAS, replacing, having multiple buildings being fed by a DAS instead of several signal boosters to avoid some side effects, having like 8 oscillation between the buildings. That was a very good part of the conversation. Now, can I ask you, if we go to a DAS solution, is there a way to provide redundancy to the DAS, so if you lose building 1, you don't lose the entire building? What do you believe about that?
So there's always a way to provide redundancy, whether you provide multiple master units and multiple remote units. If you have a remote unit built to support redundancy, it really just depends on what solution you use, whether it's multiple fibers to a building, multiple master units in, let's say, one master unit in building 1, one master unit in building 5, and have multiple fibers to each building. So it depends on the solution you deploy and how you can possibly create the redundancy and what redundancies are required.
Yeah. Good. Thank you. Yes, definitely. It's like that. I mean, a DAS can be added redundancy in another head end in another building. So if building 1 is lost, building 2 jumps in, or maybe we can even think about remotes with donor antennas as a backup. So if the fiber dies, then you have the system to be fed off the air. So there are many things we can do from the technology point of view to solve these issues. So that's why it is so important for us to be in touch with the applications by itself. Now, I have let me check the questions. To Michael says, how does automatic gain control on the uplink address near far issue? And what does the AAJ test for noise figure? If you can elaborate a little bit about that. If not, I can jump in with some extra comments.
I think we got John back here as well. So I think, to the point that was raised earlier, for me, it's not so much about the gain of the system. It's about accurately knowing what your transmit power level at your donor antenna needs to be to reach the base station. So that a strategy where you focus on the power control at that point seems to be one that's safer than just trying to focus on the gain. So the input is obviously going to be different depending on whether the handout is close to the server antenna or far away from the server antenna. But it doesn't matter actually how far away the handset would be from the server antenna. What you want to have is that at the point when the signal leaves your system and heads towards the high side, that's when the power level and the signal to noise ratio must be adequate, and so that you can reach the high side at a level that will ensure that you have good communication. So your gain control and ALC strategy should be such that you focus on what's leaving my system. Does it have enough power? Not too much. Does it have a good enough signal to noise ratio?
Okay. Yeah, I agree. And if you had a Class A BDA with such capabilities in a per channel based, you can do that per channel and make sure that one channel is not one channel AGC is not changing the gain of another channel.
Correct.
I think we have John now in. Yeah.
Yes. Hi. Are you able to hear me?
Yes.
Yep.
Yes.
And I'm sorry for that. I wound up in a different room, all by myself. So I have a question I'd like to throw out to the group. The end of the last panel ended with sort of some back and forth with some different perspectives. So I'd like to tee up a quick question, which is features in the product or expertise in the design. if the product has sufficient features, does the designer not matter? I mean, what should rule here? Because I've heard that, hey, don't worry about it. Just put it in, the secret's in the box, and it'll keep you from doing something destructive. Let me start with Al, and then I want to go through each of the OEMs for a response.
The choice of going down that path where you're going to defer to the equipment to be a be-all and end-all is really a very dangerous to take. You really want to design each system for its individual application. And if you do that, you can actually deal with products that are less feature intensive. It's not bad having the features. It's just that if you become dependent on them, you'll be lulled into a level of complacency. Very.
Okay, coming to Matt.
Yeah, I'm going to agree with Al there. You can always design a bad system, no matter how many features your BDA might have. You can design a system such that that BDA will not work for your building. So the design is definitely more important than the features. The features are just a benefit. So whether it's channelized gain, whether it's ALC power control, whatever the features are, that's just an added benefit that can help solve issues before they arise, but you need the design to be good for a good system.
Appreciate that. Thank you. Michiel.
So I think you always need a good design, but I also think that the level of knowledge that you need to come up with a good design is changing over time. I'll use an example here, right? Self-optimizing networks for LTE small cells. The concept has been around for many years, probably 6-7 years, and it never really worked that well. It's really difficult to sense the environment, figure out what's going on, how to really configure a system automatically. And today, I think there's probably very few small cells that are installed that doesn't have some self-optimizing networking capability. So I think the concept of a product understanding the environment where it's been deployed has come a long way over the last, let's say 5 years. And I think we need to incorporate that in public safety as well, right? There's no reason why it cannot be done, and cannot, at least to some extent, but probably even a large extent, alleviate some of the mistakes that people in the field make and help them to do good and safe installations.
Thank you, Fernando.
Right.
Yeah, thank you. Well, definitely, you always need a good engineering, and it has to be well deployed. You cannot, any BDA out there that is not well, accurately deployed, it's going to create problems. That's true. But then, when you start comparing, and I think I will add to what Michael was saying, is when you have several, if you compare systems that are well deployed, the difference in performance sometimes is different. For example, if you have a jurisdiction that will be deploying over the next years a big amount of BDA deployments and DAS deployments, then they probably might need to consider using a Class A type of signal boosters and a Class A type of DAS systems, fiber optic DAS systems, to make sure to, not to aggregate so much noise in the uplink. That's, even though you install a very well Class B installed BDA, will raise the noise minimum 20 dB above what a Class A does. So, I mean, that's, you gotta have the expertise. Whoever you throw out in the field, they have to know what they do, but it is important to pick the right technology. Somebody has to be thinking, above everyone, and looking of what the network would look like maybe 2-3 years from now, and start taking measurements today. And when I say measurements, I mean taking actions today to see how the system will look like when it has 500 DAS, fiber optic DAS, and remote units and BDAs installed in the city. They have to look what they want to see in the uplink, for example, and also for the near far inside the building. Also, there are differences in technologies, and there are systems that deal that better than others, and can become critical if it's not taken into consideration in time.
Thank you. So earlier today, there was a keynote by Ed Parkinson from FirstNet. He talked a lot about future investments. He talked about things like 5G, for example. And then in yesterday's keynote, Chief Jeff Johnson talked about how important it was for FirstNet to work inside buildings. So, starting with you, Michiel, where does FirstNet fit in the in-building public safety conversation?
I think not just in the US, I think this is going to be a worldwide trend, right? Public safety LTE, I think, is here to stay. It is here to grow. It will provide a level of service that first responders will come to rely on. And so I think from us, from a company point of view, we are 100% committed to seeing FirstNet become just as big a part of the conversation as LMR radio is today. Clearly there's focus from the code side, etc., on two-way radios, but I think that it's just a matter of time before we see that conversation change. The moment that we can actually see lives being saved through the access to situational awareness information that FirstNet will provide, I think that's the point. That will be the tipping point. We will, sit with the nature of the conversation changes.
Thank you, Matt. What impact has the rolling out of UL 2524 had on the in-building industry, for better or for worse? Like, what has the impact been?
I think one of the impacts is that it takes longer to get an approved product, but that's a good thing. The good impact is that there's an actual standard for BDAs now, whereas really there wasn't a standard before. There's the FCC guidelines, there's an FPA code, but there is nothing telling you exactly what your BDA needed to look like, what the power was supposed to be, or anything else. So UL 2524 really officially came out with a standard, and now everyone can point to that standard and say, okay, does your BDA comply with this? If so, then it's good. If not, then come back to us when it does comply with UL 2524.
Thank you. Question for Fernando. Fernando, do you ever foresee a future where, rather than being off-air systems for public safety, we'll ever see a connection directly to the base station the way that you see in the cellular world? You might be on mute there, Fernando.
Thank you about that. Yeah, definitely. I see that as from the technological point of view, the way to go. At the end of the day, if you see how what's the evolution here, a lot of in-building deployments are happening with BDAs, and we saw that in the cellular world. And it was a moment in which, we need to change the technology because so many donor antennas are creating a problem. And definitely there are, and I can tell you that there are jurisdictions interested in this, making a whole, like a city, like managing the indoor from the city. So envision like a city-wise DAS system in which you have a base station with a master unit and fibers to the remote units. I can definitely see that, and we as an industry, we should come up with solutions that would only work on those scenarios, but also provide the enough redundancy to make sure that we will comply with what it is understood the standard for public safety.
Thank you. I appreciate that. So, Al, can you talk about? Yes. All right. So we have to wrap right now. Final word, Al. The importance of a wireless master plan, and then thank you to all the panelists for their participation. Al, if you could wrap up in 1 minute.
Yeah, having a cohesive plan to figure out how you want to deploy for the AHJ or authority having jurisdiction is essential. And what they want to derive, working with either their consultants, their integrators, their subject matter experts to figure out all the things that are critical to them is very important. Doing it well right from the get-go will eliminate a lot of reworks and changes and modifications to the overall system, and will make it a lot better in terms of safety and performance for all the users. You don't want to skimp at the beginning of that project and just make something either cookie cutter or not really well thought out from the city or the locale or county is looking forward to. So getting it right the first time, getting it right is really important. Thank you.
Thank you very much to our panelists. It was a great presentation. I'd like to remind everybody coming up at 2 o'clock, we have VT21 measuring indoor radio coverage, ensuring NFPA code compliance and addressing interference. I want to thank Matt, Al, Michiel, and Fernando, and to IWCE, thank you for the platform. We'll see you down the road.
Thank you.
Thank you.
Thank you.
Appreciate it.